Hello everyone. In this video, I'll be teaching you about empirical formulas, what they are, how to find them, and why they are so important. By the end, you'll feel confident solving these problems step by step. Let's get started. So, our first important question is, what is an empirical formula? The empirical formula is the simplest whole number ratio of elements in a compound. Simplest whole number ratio of elements in a compound. So, this topic tends to be a little scary, right? But don't worry, let's make it simple. So basically, what this tells you is that it doesn't give you the exact number of atoms, like that, which is the molecular formula, which is an upcoming video. It tells you the basic ratio. So for example, glucose, right? C6H12O6. The empirical formula of glucose is CH2O. So how did we get this? Well, basically, we just simplified, right? We divided each by a common factor, which was 6, right? 6 divided by 6 is 1 for carbon. So basically, there's an imaginary 1, right? 12 divided by 6 is 2 for hydrogen. And for oxygen, 6 divided by 6 is 1. So basically, this is the empirical formula. Really simple, right? So let's get into the steps of how to determine the empirical formula. So, how do you determine the empirical formula? How to determine? Well, these are the steps. So, first, you convert the percentage or mass into moles. That's simple, right? It's in one of my previous videos, right? You just turn it into moles. So, use the molar mass of each element to turn it into moles. So for this, you would use the molar mass. Use molar mass. Basically, you divide the element or the amount of the element by the moles. So, number 2. Divide all moles by the smallest mole. By the smallest mole. So, say you divide a bunch of elements by its mass, molar mass, right? And you get the moles of it. Whichever one is the smallest, you divide all of them by that, right? So this ensures you to get simplest ratio. Ensures simplest ratio. And the third step, adjust the ratios. So say you divide and you get 1.5 or some number like that, right? Well, if you end up with a decimal like 1.5, you just multiply the whole thing by 2 so you can get more whole numbers, right? So if end up with 1.5, multiply whole formula by 2. Something like that, right? Pretty simple, pretty basic. All right, let's get into some practice problems. Okay, so here's our question. A compound is 40% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. What is the empirical formula? So, how would we go about doing this, right? Well, all of these percentages are out of 100. So we have 40 grams of carbon, we have 6.7 grams of hydrogen, and we have 53.3 grams of oxygen, right? Or grams per mole. So what we would do is we have to get each one, right? So let's get different color. Carbon, which is 40 grams per mole, right? Hydrogen, which is 6.7 grams per mole. And then oxygen, 53 3.3 grams per mole. So, if you remember from the earlier steps, I said you have to multiply all of these by their molar masses. So, grab your periodic table and let's find them, right? Molar mass is the atomic mass. So, what is carbon's? 12.01, right? Hydrogen's 1.008, and oxygen's 16. So, what will we get for this? For carbon's moles, we get 3.33 moles. For hydrogen's moles, we would get 6.65 moles. And then for oxygen's moles, we would get 3.33 moles. So, what was the next step? The next step was to divide each of the moles of each element, right, by the smallest one. Well, look here. We have two 3.33s, right? So we divide all of them by the smallest. We can choose either one. 3.33. So 3.33, 3.33, and 3.33. So this would lead us to having 1 for carbon, 1, about 2 for hydrogen, and 1 for oxygen. So what would this lead us to? Well, this would lead us to our empirical formula. So now all we have to do is take it on how we got it. So what was it? Carbon, hydrogen, oxygen. Carbon, how many did we have? 1, right? We don't normally show the 1, but in this case, I'll show it. Carbon, 1, right? Hydrogen, 2. And oxygen, 1 again. This is our empirical formula. Pretty simple, right? Not too bad once you break it down step by step. So, let's do another problem, but we're given masses. So, for this one, you would have the mass of each, right? The mass is the exact same. In percent, you would just convert the percent into mass since it's out of 100. But in mass, it's even easier. You just you keep it as the mass, right? So what was our first step? Well, our first step was to turn the compound, or like each of the elements, into moles. And how would we do that? By dividing by the molar mass. So let's get nitrogens. What do we have for nitrogen? It said 4.2, right? So we have 4.2 grams of nitrogen, right? Or grams per mole. So what is it for nitrogen? 4.2. So we have 4.2, right? Divided by its atomic mass or molar mass, which is the same thing. So 14.01 grams per mole. Make sure you don't forget the units, right? Which is equal to about 0.300 moles. Right? Now we'll do the same for oxygen. Oxygen is equal to, what does it say here? 12 grams, right? 12 grams. And we would have 16, which is the atomic mass. And when we divide that, what do we get? 0.750 moles. So, what was our next step here? Well, our next step was to divide by the smallest amount of moles, right? Which over here is 0.3. So we divide each by 0.3. And when we do that, we get, for nitrogen, we get nitrogen as 1 and oxygen as 2.5. So what was our third step, if you can recall, right? Our third step was that if we do have any decimal places, we just have to make them into a whole number. So right now our formula is N1, change the color to N1, O, 2.5. We can't have a decimal place here, right? I don't like that. So we got to fix it. We gotta multiply this whole thing. What could we multiply 2.5 by to get a whole number? 2, right? So you do 2.5, multiply the whole thing by 2, which would end up as N2O5, which is the empirical formula. So why do we care about empirical formula? Well, they help scientists determine the composition of new compounds. They're a stepping stone to finding the molecular formula, and empirical formulas are essential in analyzing and identifying chemical substances in labs and industries. So let's do one more challenge problem, which you guys will try by yourself. Okay, so our challenge problem here is a compound is 24.5% potassium, 34.8% manganese, and 40.7 oxygen. Find the empirical formula. So remember to follow the steps. So start by assuming it's 100 grams. Each one is 100 grams. All right, how about you guys pause the video, try to find this on your own, and then I'll go step by step. Okay, so hopefully you guys have got your answer. So let's go through it step by step. So what's our first step? To convert mass to moles. So we'd have 24.5 grams of potassium, right? So this is for potassium. And we have to find its molar mass, right? On the periodic table, it's the atomic mass. So 39.1 grams per mole, right? Which is equal to 0.626 moles, right? So next we're going to do manganese, Mn, right? So we have 34.8 grams of manganese, and we divide it by its molar mass, which is 54.94 grams per moles, which is equal to 0.633, and 0.633 moles. And our last one, oxygen, which we have 40.7 grams of, when we divide by 16.00 grams per mole, right? Which is equal to 2.544 moles. So what is the smallest one out of all of these? Well, the smallest one out of all of these is 0.626. Let's divide all of them by 0.626, 0.626, 0.626. Let's scroll down here. And so from here we would get, for potassium, we would have 1, right? For manganese, we would have about 1, approximately 1. If it's close, like pretty close, you just round up 1. And for oxygen, you would have about 4. So from here, we can write our empirical formula as K, right? K1, N1, and O4. This right here is our empirical formula. To recap, the empirical formula gives the simplest whole number ratio of elements in a compound. You calculate it by converting mass, or percent, to moles, dividing by the smallest number, and simplifying to whole numbers. With practice, these steps will become second nature. I promise you, these are some difficult practice problems. If you could do this easily, you're in good shape. And if you couldn't, just keep practicing. If you found this helpful, like and subscribe for more easy-to-follow chemistry lessons. Thanks for watching, and see you next time.